Hi everybody, this is Jay. I'm here to show you a tutorial on using combination of the rules we've talked about so far involving exponents, and that will be both the power rule and the product rule. So let's look at an example where we apply both of these rules. In this problem we have 3 over 4 raised to the second power times 3 to the fifth power. Okay, our first step should be apply the power rule to what we have in parentheses. So we're going to raise 3 to the second power and also raise 4 to the second power. So it looks like this. Now we can multiply. And when we multiply, we're going to multiply using the product rule. And when we multiply using the product rule, we add the exponents. So look at 3 to the second times 3 to the fifth. We add the exponents, and similarly 4 squared times 1 will just be 4 squared. So 3 to the second times 3 to the fifth, 2 plus 5, we get 7. So it becomes 3 to the seventh all over 4 squared. And that will be our final answer. Okay, now let's look at another example. This one involves using the combination of rules to simplify a more complicated expression. We have 7m squared n, and it's all raised to the third power. And then we have 7m squared n raised to the fifth power. Now, while this problem may look complicated, it's very simple. The key here to recognize is that we have the terms that are in the parentheses are both the same. So what we have is the same base, and the base is 7m squared n. So remember, when we multiply two terms with the same base, what can we do? Well, we can apply the product rule and just add the exponents. So what we can do is look at this problem and say exponents are 3 and 5, add the exponents, and it becomes a new exponent of 8. So we have 7m to the second power n, all raised to the power of 8. Now it's starting to look a little more simple. We still have to simplify further, and we can do that by applying the power rule. And the power rule tells us to raise each term in the parentheses to the 8th power. So what we do is we raise 7 to the 8th power, m squared to the 8th power, and remember, to do that we multiply our exponents to get m to the 16th, and n to the 8th power is just n to the 8th power. And this is our final answer, simplified. Okay, I think we're ready to try a few more challenging, involved examples. Let's look at this one. We have two expressions being multiplied together. Now, first thing we do is look and compare both expressions, what's in the parentheses. Are the terms in the parentheses the same? And the answer is no, they're not. One has an x to the third power, the other has an x to the seventh. One has a y, the other has a y to the fourth. So the bases aren't the same. So we can't, at this point, multiply and add exponents like we did in the last example. Instead, we have to simplify first by using the power rule. So let's apply the power rule. And when we do that, we apply it to the first expression. Everything in the parentheses for the first expression we raise to the 6th power. So we raise 2 to the 6th power, x to the 3rd to the 6th power, and y to the 6th power. Also apply the power rule to the second expression. So everything in the parentheses we raise to the 10th power. 2 to the 10th power, x to the 7th raised to the 10th power, and y to the 4th raised to the 10th power. Now, once we take the time and break the problem down like this into smaller parts, it becomes a little bit easier to work with. And now at this point, we can apply the power rule again to each individual term. So 2 to the 6th power, when we raise x to the 3rd, all raised to the 6th, we apply the power rule and multiply the exponents. 3 times 6 is 18, so we get x to the 18th. Y to the 6th, 2 to the 10th power. Now look at this one. We have x to the 7th raised to the 10. Multiply your exponents. 7 times 10 is 70, so we get x to the 70th power. Y to the 4th raised to the 10, we get y to the 40th power. So now we've simplified further, but are we done yet? No, not quite yet. Now we have to look at the terms that have the same basis and we combine them. We can multiply them. And remember, now we're using the product rule. When we multiply these terms, we add the exponents. For example, 2 to the 6th times 2 to the 10th. X to the 18th times x to the 70th, because they have the same base, and y to the 6th times y to the 40th. For each of these, we add the exponents, so we get 2 to the 16th, x to the 88th, and y to the 46th. And this is our final answer. The problem is now completely simplified. Okay, I think we're ready to do one more example. And if you can follow the last example we did as well as this one, then I think you're well on your way to practicing more and understanding how the combination of rules work. Okay, so let's look at this problem again. Look what's in the parentheses. We always want to ask ourselves, is the same thing in the parentheses? Because if it is, we can right away multiply them and apply the product rule and add the exponents. But when we look what's in the parentheses, it's not the same, is it? So we cannot do that for this problem. Instead, we have to use the power rule on each expression. So everything in the first expression we raise to the second power. Everything in the second expression we raise to the third power. When we do that, it helps to factor out the minus in front of each and just call it a -1 to help you visualize. And then raise each term to their respective powers. -1 squared, and then g cubed to the second power. Multiply the exponents, we get g to the 6th, h squared, -1 cubed, g to the second raised to the third. Multiply again, we get 6, g to the 6th, h to the 5th raised to the third. 3 times 5 is 15, so we get h to the 15th power. Now let's apply the product rule, and we add exponents for all the like terms. So -1, we have that raised to the second power. We also have it raised to the third power. 2 plus 3 is 5, so we get -1 to the 5th power. G to the 12th, and that's because we have g to the 6th times g to the 6th. 6 plus 6 is 12. H to the 17th power, and we get that when we multiply h squared times h to the 15th. 2 plus 15 gives us 17. We keep the h, so it's h to the 17th. Can we simplify this any further? The only other thing we can do is -1 to the 5th power. If you multiply -1 together 5 times, it's just -1. So we can write it as just -1 or even just a negative in front. And when we do that, we get minus g to the 12th power, h to the 17th power. And that's our final answer.